In this session, I will introduce classes, objects, and instances. Classes and objects help make our program more organized, powerful, and easy to reuse. We create a class to represent people, places, and things. A class represents a condition of the real world. An object is based on a class and use the class as a blueprint to create an instance. Therefore, each object is automatically supplied the same attributes and methods of a class. Create an object from a class is called instantiation, and we work with instances of a class. To create a class, we write the keyword class. So far, in the previous sessions, we have covered some basic data types like int, string, let me spell that right, float, and Boolean. Python also offers some data structures like a list. However, not all data falls under these basic data types. These are built in. As a result, Python allows us to create our own data type using a class. For example, a dog or a cat does not have a representation in one of these built-in data types. So to create our own data types, let's say we have an employee, and to represent an employee, that means our class will be called employee. And I cannot forget the colon. Notice employee starts with a capital letter. By convention, the name of a Python class begins with a capital letter. If you had a class that you wanted to leave empty, then we write pass. The purpose of pass is to let Python know you want this class to be a placeholder for future code. It helps to avoid getting an error. For example, if I comment pass, then write emp1 equals employee, then run, we see an error. If I remove the comment, then run again, now we do not see an error. Exit code shows 0. Now we see a line under employee. There's a line under employee because I have not added a doc string. It's missing. The doc string is not required, but it describes the class. I will add a class for an employee's information. Sometimes there's confusion around objects, classes, and instances. The employee class is a template for the employee object. The employee object is assigned to the instance employee1. For example, name equals Joe Doe. Joe Doe is assigned to name. It's the same with objects. Employee1 is not the object, but refers to the object. I'm going to remove name equals Joe Doe, and we see employee1 is an instant variable and created when we instantiate the employee object. That's why we say employee1 is an instance of the employee class. You know how a company can have more than one employee? We can also create more than one instance of an employee by writing emp2 equals employee. Now we have two instances that refer to the employee object. At runtime, the employee object allocates memory for employee1 and employee2. Let me show you when I print emp1, and print M2. Run, and the console shows different memory locations. It shows different memory locations because the employee object has memory for 2 instances. That means the employee class will return an instance or reference to employee 1 and also return a reference to employee 2. To verify there are instances of the employee class, we can write is instance. Then pass in 2 arguments, the instance, employee 1, and the class, employee. Also print. I'm going to copy and paste and do the same for employee 2. Now, when I run, we see true 2 times. True means they are instances of the employee class. That's the difference between a class, object, and instance. To recap, the class is a blueprint for the object. Therefore, an object has a copy of all information from the class. That information is called attributes and methods. We only access attributes and methods when creating an instance. In this example, the employee object encapsulates all of the information from the employee class, then allow employee 1 and employee 2 to access that information. Next, I will create information and show you how to access that information. Thanks for watching, and I will see you in the next session.